Hi, this is Kevin Trainer, and welcome to my tutorial that's an overview for the final project that you're going to be doing for INFOST 350, which is the Python course. Okay, so what I promised to provide was kind of an overview of the assignment. I just finished a couple of hours ago the instructions for the assignment, and I think they're more detailed than I thought they were going to be. So I'm going to repeat some of the facts, or some parts of the instructions, in order to emphasize them. But I encourage you to read it from beginning to end before you do the final project assignment. The final project assignment is 4 pretty big exercises. Some considerably bigger than we've had before, and some about the size we've had before. I think this really turned out to be just about the size I had in mind. Okay, and the project that you're working on, they're all related exercises, is kind of a data science project. I picked a data set that has population data for Milwaukee County. And you're going to work with the data set in a way that you would on, it's kind of a data analysis kind of project. So the 4 parts are going to be this. I've introduced some errors into the data because a big part of data science is what people typically call data cleaning. So exercises 1 and 2 are cleaning the data. In exercise 1, you're going to be creating a program that helps to show the errors that we have in the data entry by exposing the rows in this data table that don't add up to the total that's all the way on the right side in the last. You're going to be working to clean up the discrepancies there, clean the data. And so when you're done with that process of creating the program and then cleaning the row level errors in the data, well, then you'd be ready to go on to find the errors that are in the columns. Okay. So in exercise 2, you kind of like in exercise 1. And in that, you're going to be creating a program that exposes the errors in the math, in the adding up of the columns. Okay. And again, you're going to be expected to correct those. And when you're done, you're going to be able to run the program and see that all those errors are gone. So pretty cool, right? In the third part of the assignment, you're going to be creating a custom class for use in exercise 4. Exercise 4 is going to be creating and running a set of data analysis reports. But the best way for us to handle the data is by creating a custom class to hold that data. It holds essentially a row of the data that's in the table. So you're going to do the kind of things that we did in the assignment for classes. That assignment had one version that you did was a basic version, and another version that you did was the evolved version. And this one is going to match up pretty closely with the evolved one. Okay, and then finally, you're going to get into exercise 4, where you're going to You're going to write the code that creates two sets of analysis of report. One that reports the counts of the population, and the other that reports the percentage makeup of the population. And I'm going to walk you through it, but that's the overall view. So this might be a project that you would get at work, and that's what we're trying to do. I have a disclaimer in the beginning of the instructions that says the following. The data set that we're using divides the population into male and female. And I'm sure a lot of you are aware that not really everybody in the world these days identifies as either male or female. They have a much more nuanced gender identity than that. Now, we picked the data set out of expediency, but I don't want this to appear as some kind of a non-support for people who have gender identities that are more complex than the data supports. Okay, because for all of you who fall into that category, you definitely have my support, and for all the rest of you, I encourage you to support people with non-binary gender identity as well. Okay, so feel free to read that. I even have a link here to the Wikipedia article on gender identity. See if we can get that to pop up. And I think it's a pretty good article. It's a good starting place for people who maybe haven't been thinking about this in such a complex way. Okay? Good. Okay, so where does the data come from? Well, the data we're going to be working with comes from the Wisconsin Department of Health Services. And they have a lot of data sets, a whole bunch of them. And there is population data for all the counties. So the one that I picked was Milwaukee County, because that's where our school is. So if I click through here, you'll see the page I got the data from. I'll allow it. Okay, and so the most recent year that they had the population data for was 2014. Okay, and the view table pops up a picture of that data. Okay, and I have this page as an appendix to our instructions. I've just added the words Appendix A up top. And the part of the data we're going to be working with is this first grouping on the top left. Okay, so this is from July 2014. It breaks the population up into these age groups. It also breaks it up into males and females, and it totals them. We're not dealing with this percent change information. And we're also not dealing with the second set of groupings they have for the same data, which are broader age categories. I would have used that, but it didn't have enough data to really make the assignment interesting. So you don't have to download the page. I did it for you. It's an appendix to the instructions, and you don't have to download the data because I downloaded it and I converted it to a text file, and I cleaned it up so it's going to be easy to read with a Python program like we've been doing. And I introduced some data entry errors so that we could get some practice fixing those and practice writing the kind of programs you have to write to make those visible so one can go and fix them. And whether you as the data scientist or the programmer would fix that data, or whether you would show it to some kind of users who you're working with and they would go back and fix that data, it probably just depends on the organization that you're working in. But in your project, you're going to be all those people, right? So you actually are going to clean the data. Okay. Now, you're going to be working a little bit more independently on this than in the homework assignments. Okay. This is the final project. This is the real deal. Okay. So a couple of things. One is that the grading rubric for this, I put together a grading rubric for this is my typical final assignment kind of grading rubric. It doesn't have a guarantee that you'll score a certain amount if you show a good faith effort and hand it in on time. Okay, you have to earn every point. Okay, so start early and ask for all the help you need. All right. The next thing is that in most of the assignments that we did for homework, I gave you guys a tutorial video for a program that was pretty close to what you were going to be doing. And I didn't really think that's appropriate for a final project, but what I did do is I did give you more help in the instructions. I tried to make them kind of like a specification that I would create for a junior programmer who just joined my staff. Okay, somebody who had a Python course. I wouldn't consider them fully independent. So among other things, I give you the pseudocode and I give you a bunch of hints along the way. And I think that should serve you pretty well. For those of you who are more senior programmers, you probably wouldn't need that much help. But for those of you who this is first time out, I wanted to have that there so that you could refer to it if you need it. We're going to be giving the same amount of help to you guys on this final project that we did with the homework assignments. So as for me and for Julie, the TA, we're here to help. So we'll talk about the final project in the remaining online labs. You can contact us via the request center portal and ask for help. And to the extent that you need any help at all, ask for it early and ask for it often. Okay. It's okay to help each other. I don't want you to give each other your code. So just like we've been doing all along, if you have a problem, it's certainly okay to show your code to a classmate or a friend and say, well, I've got some problem with it. Could you help me identify the problem? Or could you suggest some things I could do to improve this? Okay, so interacting with each other and supporting each other, that's a really good practice that we do in the workplace. So I'd like you to be able to do it for the final project. Just don't give each other your code. All right. I have this list of the expectations, and it kind of grew from the list that I had at the beginning of each of the homework assignments. And these have really just become the requirements that I put into the grading rubric. Okay, so I put some additional ones in the end that reflected the requirements for custom classes and such. Okay, not going to go through them. Um, there's a zip file available with the starter files in it. Okay, and when you unzip it, there's two text files, one called raw data, the other called cleaned data. In a data cleaning kind of process, you begin with the raw data and then you work with it until you consider it to be clean. Okay? And generally, what you do is you keep a copy of the raw data in its pristine and gnarly states. That's what raw data.txt is. Clean data.txt is the one you're going to be working with. So it's going to be the input to really all of the programs that we're going to be doing. So that's exercises 1, 2, and 4. Okay. And when you're working on exercises 1 and 2, when you run your program the first time, you'll see all the errors, and then you'll correct them and they'll go away. And then you go on to exercise 2, where you're correcting the column errors. So by the time you get down to using the data in exercise 4, it should be cleaned. Well, why did I give you 2 copies of this? Well, if the cleaning goes haywire, okay, and you decide that you've really crapped up the data, okay, you can always just go back and start again by copying raw data over top of cleaned data and going back to the beginning. Okay, so that's just kind of a emergency backup point. And that when you begin, these files have exactly the same contents. Okay. So in exercise 1, as I said, we're creating a program to identify row-level data entry errors. So we have a file. In fact, let me open this file here. Let me take this raw data file that I have. Well, I cleaned it. Data has the same thing in it. I just made a big point to tell you that. So I'm going to open this. Okay. Let me get it. It's coming. I promise it's coming. Here's what it looks like. Maybe we can make the text a little bigger. Yeah, there we go. So this is the data that we saw when I showed you the PDF. Okay. Here's how it reads. Okay. This column over here in the instructions, I call it, in the beginning I call it label, and later on when we create the custom class, I call it category. It's both it's a category label, right? That identifies the age group. And then we have the count for males. And then we have the count for females. And then we have the total count. Okay. And before I corrupted the data, these added across the rows without error, and from top to bottom on the columns, because there's the last of the rows is a total row. Okay, so when you're doing the checking, when you're doing exercise 1, you're going to make sure that these things add across the rows. When you're doing exercise 2, you're going to make sure that these things add down the columns. Now, you can't add the category label column, but you can add the other 3, and they should, they should add up to the penny, although they're not pennies. They should add up to the person. Okay. So let's take a look at the report you're going to create. What it essentially does is the program is going to be adding for each of the rows. It's going to be adding the males and the females and comparing that to the stated total. And if they if the total that you get when you add these things up is equal to the total in the total column, then the error is going to be 0. Okay. If what you add is less than what's in the total column, you're going to have an error that's negative. So here, somewhere in these columns, we lost 40 people. Okay. Down here in this in the age group 35 to 39, somehow we got these things messed up. We're over by 180 people. Okay. And then down here in the 65 to 74, we're over by 790 people. And how are you going to resolve this? Well, one, you'll see the lines that have the error. Okay. Two, you're just going to go and let me show you this. You're just going to go back and proofread the lines and correct the lines. Okay. And then you're going to run the report again. And when you correct that line, which you can do in your text editor, right? Sorry about that. When you correct that line and come back, you're going to run it again, and the error is going to go away. So when you're done with fixing these 3 rows that have errors, all the errors will be 0. Okay? And I show you what that looks like right here. That's how you know you're done. Okay? So, how could you do this? Well, I bet you have some ideas about how to do it. Here's my pseudocode for the program. Okay? And it's pretty good pseudocode because I've actually created the solutions to these, and this is my kind of condensed backward pseudocode from code that actually works. So this is not pseudocode that might or might not work. This is the pseudocode version of the code that I created that actually does work. All right. Now I've created some hints. Okay. We're doing some interesting things in the formatting. Like for instance, we have a title that's exactly centered. Okay. Now, did we practice that in one of the homeworks? No, I don't think we did. Okay. We have on the detail lines, we have inserted commas to separate the thousands out. Okay. Did we do that in one of our homework assignments? No, I don't think we did that either. So one of the things I do is I show you, first of all, I tell you that these lines are 50 characters wide. So there are 5 10-character wide columns. So that's what you're supposed to do. The report titled is centered in the 50-character line. Okay, a format string that would be useful for doing that is this one right here. Okay, and a format string that would be useful for printing these counts right at justified with a comma separator is this one right here. Okay, so this is just the format for the second of the fields. You remember the first one has the number 0. That's what we have for the title. And then the next one has the number 1. Okay. And these are all the same. So I wasn't going to give you all of them, but you expect them to be the same. Okay, so that's a lot of hinting. Okay, but you have to make it work, and you have to make the report look like I have here. So I want it to be 50 characters wide. I want you to skip the same number of lines, um, the whole deal. Because in fact, if you worked on my team and I gave this to you, if I gave you kind of specifications that look like this, I wouldn't want you to come back with a report that was inspired by my report. I want you to come back with this report. Okay? Okay, so that's exercise 1. In exercise 2, we're creating another program. This one's called Detect Column Level Data Entry Errors. Okay, and what it does is it takes a little bit more coding because you have to accumulate down through these columns so that when you get to the bottom, okay, you can compare what you've added up to what is in the total line. Okay, so you have to know when you get to the total line, right? Okay, and then you have to have accumulated all the males and all the females and all the totals all the way down, and then you have to compare them in order to get the error line. Okay, so again, the data has to work across the rows and down the columns. Okay, and then how are you going to find them? Well, you're just going to go back here, right? And you're going to say, okay, what's wrong here? Okay, first of all, is there something wrong with the total? Okay, if the total's off, if I've done that, well then that's probably easy to fix. Okay, so you're going to have to jockey with the data until you get the columns to foot down at the bottom. Okay. So what did I give you for this? Well, first of all, I showed you the report with the errors. The errors that you have here, this is what you should see if in exercise 1 you got rid of all the row errors and then you ran it right here. These are the errors that you should get when you start to work on the column errors. Okay? When you're done, it should look like this. So the column should add all the way down and they should equal the stated totals. Okay? So the error row should be all zeros, just like in exercise 1, the error column when we were done is all zeros. And I gave you some pseudocode for that. Okay? Now I just want to point out that because we have to treat the total row specially, okay, you have to be checking when you're going around your loop whether or not this is the total line. Okay, because you want to do certain special things when you get to the total line. And I've got a group of hints again. And I believe, yeah, well, it's pretty much the same. Oh, the report isn't as wide anymore because we don't have that error column on the right. So now it's only 40 characters wide. If you look over here, there are only 4 columns, 10 characters each. Okay, so the report title is centered in 40 on a 40 character line, and I give you some format strings to help you do that. Okay. All right. So now you're ready to create our custom class. Okay. The custom class goes on its own module because we're going to import it when we use it in exercise 4. The module is going to be called My Population Groups. Typically, modules that you share with other people just have one long lowercase name. I've tried to give ourselves multi-word module names so that we would know that the stuff that we created is different from the stuff from either the Python software people or from third parties. And that's why the first word's always my. Okay? So whether you would want to do this as a steady diet for naming your modules, I don't know. But at least it's not going to collide with anything. Okay? So I've got a bunch of requirements for the class. You can just read them down, and this is a class, again, if you want to compare this to one of the exercises from the homework assignment that we had for custom classes. This is the one that we call the evolved version of class. So it's got instance variables for category, male count, female count. We don't store the total count because it can be derived. And then how do we get it? Well, we create a method for the convenience of the user where we call calculate a total count, and we get the total, but we don't store it. We just recalculate it every time it's called, and we return it. I want to do the same things with the fields that we did in the evolved version of the class, which is to say we want to use these property decorators to create a getter-setter pair. The getters are just going to be plain old straight through getters. And the reason that we're having them is that you need to have if you're using this property decorator approach to getters and setters, you need to have the getter in order to get the setter. And the kinds of checks we're doing in the setter, in the category, we don't want to set to the empty string. In the male count and the female count, we don't want to set to less than 0. And it should have a constructor called init that allows you to set the value of the instance variables. And it should have a string method called dunderstir that brings back a proper representation of one of these objects. And the kind of formula that you should use for what that should look like should be based on what we did in the homework. Like we've done like we did in the homework for custom classes, they go into a module, and then the main function is going to hold the unit test code. I want the unit tests to work like the unit tests in the homework. So you can take inspiration from them. And here's the unit test outputs. I think there are 6 different appropriate unit tests. If you can think of more, you can certainly add them in, but I wouldn't have fewer. So that's it. And we want to make sure that the unit tests run when we just run the module. We also want to make sure that they don't run when we import the module. And that's what we're going to do in exercise 4. Exercise 4 is, it looks like a lot. We're creating 8 reports. What we're really doing is we're creating 2 kinds of reports. One that reports the counts, and one that reports them as percentages. Okay. And what we're doing is that we are putting them into 4 different sort orders. Okay. So what we do is uh, we sort, and then we run the counts of report, then we run a percentages report, then we sort again, run the counts, run the percentages, sort again, run the counts and the percentages, sort one more time, run the counts and run the percentages. And so they're going to be 2 methods in your program, one that creates a count-based report and another one that creates a percentage-based report. Okay. And now I just have I have all the reports. So if you look here, there are 8 of them. Okay. I have a note here that says, when you go to test this, these are, one of the things I say is that these are interleaved. So we have a count-based report, we have a percentage-based report. We have a count-based, we have a percentage-based. Why don't we do all the counts and then all the percentages? Well, instead of sorting the data 4 times, like we're going to do in this interleaved approach, and that way we'd have to sort it 8 times. And most people would think that's kind of wasteful. Okay? So as you can see from the list up here, these are interleaved. Counts percentage, counts percentage, counts percentage, counts percentage. Now, when you're testing this, get the counts to work first. Okay? So when you run them, it's going to be counts, 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 counts. Okay? And then when you get the percentages to work, then you'll have the interleaved, all of them. All right? I just want to point out some things about the reports. The counts reports are easy to understand. Okay, they're they, as we were able to demonstrate in our 2 programs, they should add across. Okay, and then they should add down. And it really doesn't matter which sort order we're in, okay? They should always add across and add down, right? Now, when we convert these into percentages, they work differently, okay? Because what we're reporting is the percentage of the total for that column, okay? So the individual columns make sense. So if in fact you went and you added up all these values, they should add to 100. Okay, but they don't add to, across the row. Okay, in fact, what you get is kind of an average here. So we've got a 21 and a 19. What we're really saying is, what we really did is we took the total count here and we divided it by the total row and we got a percentage. Okay, so we didn't, these are all done a column at a time. Okay, so I've got the answers here. You should be matching these answers, right? If you're not matching the answers, you've got your math wrong. All right? Okay. Now, what else did I give you? It looks like a lot there, but again, you've only got to get two different reports to work. They're just 4 sort orders. Okay, and that would be pretty typical. Now, why do we need all these reports? Well, they're kind of interesting. For instance, I'm kind of interested if we sort this by the male counts, is is the age group order going to shift compared to when we sorted by the female count? And it turns out when you look at these, they're not that different, right? You could see these things seem to happen in the same order, okay? But you can see some interesting things. Um, One of the interesting things is to look at, for instance, um, well, look at this. I think it's really interesting here that there were so many more young males in Milwaukee County in this time frame than females. Nearly 4,000 more. Okay, so when you look at this, um, the males were 21% of the overall uh, male population, and the females were only 19% of the overall population. I don't know how you explain that. I mean, typically the same number of males and females are born approximately. I think there are. Uh, I think there may be a few more females that are born. I could be wrong about this. I'm certainly not a population scientist. The other thing is to see how they trail off over time. So when you get up to my age and older, uh, you can see that the percentage of the populations that are male and female start to differ. So they're pretty close. Um, Before you once you get over the anomaly in the 0 to 14 age group, but they're pretty close all the way up to maybe 65 to 74. But once you get over 75, only 3% of the male population is over 75, where 4.24% of the female population is. And then at 85 plus, only 1.25% of the population is 85 plus, where in the females it's 2.61. So that's more than twice as many. And that's consistent with what we know, that we've got more elderly women than elderly men because women seem to have a longer lifespan. But so, in terms of analyzing the data, we're kind of playing at this, right? Okay, we want to get reports that have exactly the answers that you see. All right, I've already shown you the answers, and you can take some time to noodle through the data and see if you see some further things of interest. Okay. All right. And what did I give you? Pseudocode, a lot of it. So what I did is I gave it to you by function. All right. When we're going to call another function, I use the word do. So if I say do build population group list, there should be another function called build population group list. Okay, now I'm not going to go through here too much, but I just do want to talk about build a population group list. And here's the issue that I want to point out. Um, we're not creating um, an object, one of our customs objects for the total line. So if we come over here and we look at the data, these this report has a total line, okay? And then if we look at the data set, okay, if we actually look at the text file, there actually are numbers in here for the total line. Do we store an object for the total? No, we don't. It's typically not done, okay? Typically, when we store data in a data structure, we don't store data that can be derived. Okay. And so we're not storing the totals for the rows. Okay. We're going to calculate them every time we need them. And we're not storing the totals for the columns either. Okay. So when you look at the pseudocode for build population group list, okay, again, we're checking whether we're on the total line. Okay, because the only time that we want to actually construct a new population group instance is when it's not the total line. We're not creating a population group instance and sticking it in the list for the total line. And that's just the way people do things. Okay. For instance, if we were storing these data in a database, like a relational database, we wouldn't, if you look at the definition of the table, okay, we wouldn't have a column for the total column. We just wouldn't store that. And we wouldn't have a total for the total row. We would not store that either. Okay, and why? Because that's the way relational databases work. So a lot of pseudocode, and then some hints at the end. Okay. These are again, they're 40 character lines. Okay, so we're centering the heading within 40 characters. There are 4 10 character columns. This is the way that we're going to print a number with the commas. This is the same as we were using in the other reports. But how do we print the percentages? This is a new format string. So again, I didn't want to, because it's not a thing we had practiced, I wanted to include a hint. Okay, and let's see, what else? Typical tools, same way to submit. The file you submit should be called your last name, your first name, final project. And that's it. Oh, and there at the back is the appendix. And again, we're only interested in this part of the data up here, the upper left. That's the only data we're actually using. All right. So I want to point out the following thing. Okay, we haven't done the homework. We haven't done the homework for the custom classes. As I record this, we're just about to start the week that we're going to be doing that. So could you start the final project? Sure you could, because the first 2 exercises don't use custom classes at all. Okay? So you could get halfway through this before you finish your work for custom classes. There's not a peep of information about custom classes in exercise 1 or 2. So I'd say get at it soon. Okay, if you need some help, get help from us. Good luck with it, and I think it should be fun. I did all this myself, and I really enjoyed it. So I'm hoping that you will too. So that's it for now. I'm going to say bye. See you next time. Bye-bye.